Before the dinosaurs ever ruled the Earth, this horrifying group of early mammal-line synapsids dominated entire ecosystems for nearly 30 million years. Their jaws were capable of opening to extreme angles, likely exceeding 90 degrees in some species. They had oversized skulls built for killing and the world's first true sabre-teeth. This group is known as Gorgonopsidae. Gorgonopsids were members of the Therapsida, the broader group of synapsids that includes the direct ancestors to mammals. They lived during the Late Permian period, roughly 280 to 252 million years ago, at the time when terrestrial ecosystems were already complex, competitive and highly structured. For tens of millions of years, Gorgonopsids occupied the role of dominant large-bodied carnivores across much of Pangea. In ecological terms, they filled the same niche later taken by large theropod dinosaurs and, eventually, mammalian apex predators. Anatomically, Gorgonopsids sit at a transitional point between early synapsids and later mammal-like forms. Many members of the group were long thought to have retained a largely sprawling posture, with limbs extending outward. This would have limited their endurance, restricting them to short, powerful bursts of acceleration. However, recent trackway discoveries from Spain have challenged long-standing assumptions. These tracks belong to one of the earliest known Gorgonopsids, yet they show a surprisingly modern vertical gait. Because this upright posture appeared so early in their lineage, it raises a startling possibility that this efficient posture may have been more widespread than previously assumed. While this isn't yet widely accepted due to lack of complete skeletons, this discovery is forcing paleontologists to rethink the group's entire hunting strategy. If more members of the group were upright, they may not have been just ambushes, but potentially the world's first endurance pursuit predators, capable of breathing freely while at full gallop. This of course is a speculative take, but an interesting thought nonetheless. Their skulls, however, show clear mammal-line traits. These include a single temporal opening on each side of the skull, enlarged areas for jaw muscle attachment, and heterodont dentition, meaning different teeth serve different functions, similar to how our own teeth serve different functions. This combination produced predators that were mechanically specialised for killing rather than generalist feeding. The defining feature of Gorgonopsids is their skull. Their heads were proportionally enormous, often making up a significant percentage of total body length. The temporal fenestrae were large, indicating strong jaw musculature, but their bite force was not focused on crushing bone. Instead, the skull was built to stabilise the head during wide gapes. Many species could open their jaws beyond 90 degrees, a necessity for deploying their oversized canines without obstruction. This is a critical point. Gorgonopsids were not bone crushers. Their feeding strategy revolved around precision slicing and rapid blood loss rather than prolonged chewing or processing. Gorgonopsids represent the earliest known example of true saber-toothed predators. Their elongated upper canines were laterally compressed and blade-like, not conical. This morphology is convergently similar to the later saber-toothed mammals like Smilodon, despite being separated by more than 200 million years of evolution. To protect these teeth, Gorgonopsids evolved reinforced skulls and specialised jaw joints that allowed extreme gape angle, as previously mentioned, while maintaining structural stability. This indicates a highly specialised killing method, likely involving rapid strikes to soft tissue regions such as the throat, neck or abdomen in what is referred to as the puncture and pull method. This term was popularised by paleontologists, originally referring to the killing and/or feeding methods of theropod dinosaurs such as Tyrannosaurus rex. The Gorgonopsids were not a single animal, but a diverse family containing multiple genera and species. Smaller forms were comparable in size to modern canids, while the largest, such as Inostrancevia, rivaled modern bears in length and mass. This diversity suggests niche partitioning within Permian ecosystems. Smaller Gorgonopsids likely targeted juvenile or smaller prey, while larger species monopolised the largest herbivores available. Importantly, this size variation mirrors patterns seen later in mammalian carnivore guilds, indicating that complex predator hierarchies existed long before dinosaurs. While Gorgonopsids are often discussed as a diverse family, as mentioned, several well-studied species give us a clearer picture on how diverse and specialised this lineage actually was. First up, we have Inostrancevia. This is the largest and most famous Gorgonopsid currently known. Discovered in what is now Russia, Inostrancevia lived during the very end of the Permian and represented the apex predator of its ecosystem. It reached lengths comparable to modern bears and, with elongated skulls, massive jaw musculature and proportionally enormous saber teeth. Unlike later saber-toothed mammals, Inostrancevia retained a relatively narrow skull, suggesting a killing strategy focused on deep, precise slashing bites. rather than wide crushing attacks. Its size alone would have allowed it to dominate other carnivores and monopolise large prey. Next up we have Gorgonops. The genus Gorgonops, from which the group gets its name, was smaller but more gracile than in Austransevia. Fossils from South Africa show an animal closer in size to a large wolf or lion. Gorgonops likely occupied a mid to upper predator role, capable of hunting sizable herbivores but also competing with other carnivorous therapsids. Its skull shows classic Gorgonopsid traits: elongated sabre-teeth, a wide gape capability, and a lightweight construction optimised for rapid strikes rather than brute force. Next up we have Lycaenops. Lycaenops represents the smaller end of the Gorgonopsid spectrum. Often compared in size to modern foxes or small wolves, Lycaenops is important because it demonstrates that Gorgonopsids were not exclusively giant apex predators. Smaller species likely targeted juveniles, smaller herbivores, or occupied ecological niches that reduced direct competition with larger relatives. This mirrors patterns seen in later carnivore communities, where size differentiation allows multiple predators to coexist in the same environment. Lastly, we have Rubigia. Rubigia was a large-bodied Gorgonopsid from South Africa, comparable in size to Austransevia, but with a broader, more heavily built skull. Some researchers suggest that Rubigia may have been capable of tackling particularly large or well-defended prey, possibly including the heavily built Dinosaurs. Its skull proportions imply a greater emphasis on structural strength, though still within the slicing-based killing strategy of the rest of the group. Rubigia highlights that even among large Gorgonopsids, different biomechanical approaches existed. Taken together, these species reveal that Gorgonopsids were not evolutionary one-offs. They formed a structured predator guild with size variation, niche partitioning, and regional specialisation. This level of ecological complexity is often assumed to be a later development associated with dinosaurs or mammals, but Gorgonopsids show that it was already firmly established within the Permian. They were significantly more complex and diverse than we ever originally thought. Gorgonopsids primarily preyed upon large herbivorous synapsids, particularly Dinosaurs. They were robust, barrel-bodied animals with relatively limited speed, making them ideal targets for ambush predators. Many also lived in herds, which would have provided regular hunting opportunities. Gorgonopsids were likely ambush specialists. Their body plan does not support long-distance pursuit. Instead, they likely relied on stealth, short bursts of incredible speed, and decisive strikes using their saber teeth. As apex predators, they exerted strong top-down control on Permian ecosystems, shaping herbivore populations and influencing the behaviour of other carnivores. The ecosystems Gorgonopsids rule were fundamentally different to anything that exists today. There were no dinosaurs, no birds, no flowering plants. Instead, terrestrial environments were dominated by synapsids, early reptiles, and vast forests of gymnosperms and seed ferns. Despite this unfamiliar appearance, these ecosystems were highly productive and capable of supporting multiple large predators simultaneously. Gorgonopsids were not the primitive placeholders they are often portrayed as. They were fully integrated apex predators in stable, long-lived ecosystems. Sadly, the reign of the Gorgonopsids ended abruptly at the close of the Permian. The End-Permian mass extinction, triggered by massive volcanic activity and cascading climate effects, caused widespread ecosystem collapse. Oxygen levels dropped, temperatures rose, and food webs disintegrated. Large specialised carnivores like Gorgonopsids were among the first to disappear. When herbivore populations crashed, there was no ecological buffer to support them. Unlike some smaller synapsids, most Gorgonopsids did not survive into the Jurassic. Those rare exceptions became a dead-clad walking and quickly died out due to not being able to adapt fast enough to the changing world, ending their lineage entirely. Gorgonopsids demonstrate that complex apex predation evolved far earlier than commonly assumed. They show that saber-toothed killing strategies, trophic hierarchies, and specialised carnivory are reoccurring solutions in Earth's history, not unique innovations of later mammals or dinosaurs. They also sit close to the base of mammalian lineage, reminding us that our own evolutionary story passed through worlds ruled by creatures very different from anything alive today. For almost 30 million years, Gorgonopsids were the dominant predators on land. They perfected a killing strategy based on precision, anatomy, and biomechanical specialisation long before the terrible lizards appeared. Their extinction was not a failure of design, but the result of the most catastrophic mass extinction the planet has ever experienced. And in their fossils, we see one of the earliest examples of how complex competitive terrestrial ecosystems truly became. Before we close out the video, here's something to think about. If the End-Permian extinction never happened, would Gorgonopsids have remained Earth's apex predators, or would something else have eventually replaced them? Would the dinosaurs still have risen to dominance? Drop your take in the comments, I'd love to hear your thoughts. But if you found this video useful or learned anything new, please consider liking the video and subscribing for more prehistoric deep dives, and let me know what topic you want to explore next. But until then, stay curious.